And we'll hope you'll participate. Please add questions in the chat. This is really a meeting for the community, and so we want to make sure that you have the opportunity to ask any questions that do come up. So welcome, and we will dive in. We'll also, just as a heads up, be sharing a survey link to provide feedback at the end of the evening. So we hope that you'll offer feedback and help guide next steps for this project. And Christine, you can head to the next slide. Thanks. So for tonight's agenda, we're first going to just give a brief historical context of what's been going on with Durham's parks. We'll talk about what are soil shops, what was the project we undertook. Then we'll talk about what we did, testing for metals using a portable XRF, and what we found, results and neighborhood trends. Then we'll talk about next steps individuals can take to reduce exposure and mitigate health concerns. We'll also talk about next steps that the city is looking at for dealing with the parks issue. And then we'll have a survey at the end and hopefully plenty of time for questions. So I know we've had folks joining. Welcome, glad you could be here. And I will hand it over to Katie Bodner.
As a brief background on this project, cities across Canada and the United States have historically redeveloped land previously used for other things. Oftentimes, parks are built on land that was deemed in the past to be less desirable for other uses. In this case, Durham, North Carolina's parks represent a legacy of housing and environmental injustice. All 5 of the parks are built on land which was contaminated by municipal incinerators, wherein waste from Durham homes and businesses was burned at 4 sites in the city's formerly Red Line neighborhoods. In the 1950s, the sites were closed and converted into public parks and playing fields. Today, Walltown, East End, East Durham, and Lyon Parks. Contaminated soil from the incinerated waste was also used to fill when developing Northgate Park. In 2023, Walltown's residents' discovery of a Duke University research brought to light the presence of lead and heavy metal contamination in soil at these sites. Walltown Park, on the next slide, was officially dedicated in June 1953 as a place for recreation and enjoyment for residents. The original recreation center building was completed in 1949, 4 years before the park was dedicated and 1 year before the incinerator was taken down. Walltown Park is where the first lead contamination was located by Aniko Bihari and Dan Richter in 2023. Since that time, Durham communities have been organizing to address concerns about the contamination and to advocate for solutions. Currently, the city has closed the parks while NC's Department of Environmental Quality conducts extensive testing to understand the extent of the contamination and to understand the lines of the waste delineation, which in some cases may extend beyond the borders of the parks, near or on the property of nearby residents.
Thanks, Katie. So what are soil shops? This project is a series of 5 events called soil shops. Soil shop stands for soil screening, health, outreach, and partnership. And they were held for residents near the Durham's 5 contaminated parks. We started this project because many residents near the parks were raising questions about the soil quality around their home, learning that some of it could include some of the incinerator contaminated soil. And so through support from a grant from the Robert Wood Johnson Foundation, last fall, we launched a collaborative project to host neighborhood soil shops for residents living near the parks. So through the course of the project, we worked with an amazing team of canvassers who knocked on doors around the neighborhoods near each of the 5 parks. They chatted with community members, they collected soil samples, and they promoted the upcoming events. And then after each canvass, we hosted a neighborhood event near each park for residents to bring soil samples from their homes for XRF testing. At the soil shops, participants could also access resources on protecting health, They could speak with public health experts and soil scientists and learn more about
So
the
these
park.
people have done
Learn,
studies on.
sorry about that. Learn more about the parks issue and talk about plans for the future of the parks with folks from the city. And then finally, data was analyzed and shared back to participants as individual results or in aggregate, depending on how they opted to receive their results when they submitted soil samples. So in total, 106 residences provided 233 samples for soil testing. And I will hand it over to Owen for the next slide.
Thanks a lot. I'll
Sorry,
take a
Alex.
second to introduce myself here. Um, so I'm Owen Duckworth, and I'm a professor in the Crop and Soil Sciences Department at NC State University. And I'm representing the NC State team who helped out on this, which includes Lacey Brown, Alina Jones, and Dr. Katie May. Uh, Next slide. So what I'm going to guide us through here is a little bit about about general contamination of soils and also how we did the analyses here. So the first question is how do metals get into soils to begin with? How do toxic metals happen to be in soil samples? Why is the value we're reporting here? Why do we not necessarily expect it or want it to be zero? Well, for starters, they occur naturally. So there's a certain amount of metals that just are in soils based on the rocks that they formed from. So there's a certain amount of soils that are naturally. So we're generally less concerned about those in most cases than we are ones that come from other sources. And uh, next slide's great. Um, and there are lots of other sources, particularly in cities. As we just learned, there's a long history of human activities in the Durham area, and a lot of those activities can result in soil contamination. So things like old paint or mining or industrial activities, waste disposal, potentially movement of materials from floods, and legacy waste. That's actually a picture of an old incinerator that was in Raleigh, representing that legacy waste picture there. So lots of different ways we can have contamination. Next slide. So why do we care about that? Well, we care because people can be exposed to these potentially toxic metals through soils. So one way is through gardening. If you have a garden and you consume produce from it, the produce can sometimes take up some of these metals and have it actually in the produce themselves. Or the produce is grown in soils, and therefore there's always a little bit of dirt or soil associated with what you're eating. So potentially that could get ingested as well. So always be sure to clean your produce really well. House dust. So when you come in from outside, you bring in soil with you, and this makes up a fair component of the dust that's in your house. And then that you can then end up ingesting that or inhaling it. So making sure that you take off your shoes when you come in your house and try to keep dust to a minimum is a way to reduce exposure to. And for a certain set of people, mostly younger people, but also sometimes people like me who like to play in the dirt, can get it from touching and ingesting soil. So going out there and playing in the soil, doing fun things that kids and sometimes big kids do, um, can also result in exposure. And this is really important because next slide, uh, in particular lead, but also for a lot of metals, children are more vulnerable to the effects of metals. And of course, even though I like soil, they're probably more likely to eat some than I am. So um, there's a more issue of exposure through potential ingestion for children. Next slide. So how do we measure metals in soils? So traditionally, the way we've done this, we'd go out and take a soil like the canvassers did, usually some way to try to get a representative soil that represents a high traffic area or a garden or somewhere where you think there might be exposure, maybe where a child plays or a playground. And we would take that back and we would dissolve it in some acids at high temperature. And that's not the best thing to do. We're careful about it. We have the equipment to do it, but it involves acid. It's a little bit dangerous. It's certainly slow and labor intensive. Then we would filter it out and we'd quantify it on an expensive machine called an ICP-MS. Um, that machine breaks a lot um, traditionally, and it really makes this process more costly and more difficult and have a fairly long lead times and turnaround times. So next slide. What we've done in for this testing is we've used a XRF. I know you've heard that already said a couple times. It stands for X-ray fluorescence analyzer. And what this machine does is it shoots high energy X-rays into a sample, and that excites the sample. When the sample excites, it starts giving off its own X-rays. Each element in the sample gives off its own characteristics X-rays. So, like at a specific energy. So, if we count X-rays at specific energies, we can tell what the sample's made of. Pretty quantitatively. We call these screening values because they should be backed up with additional testing if we find something that's above one of our NC safe limits. Uh, but values should be considered relatively accurate, at least for screening purposes. Um, this can be done in a matter of minutes. It can be done on site, and it really makes things a lot quicker. There's no digestion needed, no acids needed, so it's really good for that. Next slide. So we can tell you what metals are present, and we can tell you how much it is, and we can make recommendations for reducing risk based on what metals might be there and what concentrations are there. There are some things we can't tell you though. So next slide. We can't tell you the source of any contamination. We don't know when it happened or what caused it based on just the measurements we're taking. There are also other contaminants that we can't see with this technique. So things like pesticides or PFAS or solvents or petroleum, things like that, we can't determine with this technique. So if those are suspected, additional testing using different methods would be needed. Um, Next slide. So how would you use this information? So this is really meant to educate and guide, right? So to help you make better decisions, to help you have information to make the choices you need to make. So this could be decisions based on land use, maybe what you want to use parts of your yards for and affect the relationship with your yard. Maybe you want to change the way you garden or depending on results, or maybe change where you have activities in your yard. Also to inform risk reduction behaviors, like potentially hand washing or maybe not wearing those shoes when you come in your house. And of course, something that we have no control over, but if property is transferred, i.e. if a house is sold, and you have contaminated soil, you are obligated by law in North Carolina to divulge that information. Next slide. So what did we test for and what did we use for reporting limits? Well, the first thing we tested for is lead. Lead's a really widespread contaminant. We used it for a lot historically in things like paint, gasoline, um, plumbing. So there's a lot of potentially opportunities for lead contamination in urban environments. EPA has set a limit of 200 parts per million for screening for that. So that's what we adopted as our NC safe level. So if it's above that, there's additional testing or additional testing is recommended, and as well as maybe some of these risk mitigation methods. Arsenic is another one. Arsenic is pretty common in rocks around here. So there's a background level of 5 to 7. We adopted 8 as our NC safe level. So above that, we reported it. This is largely informational and to again try to modify some of these behaviors. It's important to note that if one of these values exceeds our safe level, it really suggests that there's an increased risk, but it doesn't. It's not something that you should really be frightened of. It's something that you should be thinking about and thinking about how it might impact your behavior. We also began reporting cadmium at the beginning of this exercise, but um, we decided that we weren't really able to report it accurately because we were having issues with the with uh, interactions with high organic soils and potentially giving us false positives, false negatives. And since we didn't really think the results were um, as reliable as we hoped, we reported these early on and then stopped reporting them in later tests. So, um, yeah, I think that's the next slide. I think this might be handed over to Chris.
Yeah, good evening, folks. My name is Chris Lamont Brown, and I work for the North Carolina Environmental Justice Network. And I had the pleasure of going through the results that Owen and others were able to analyze. And so the first thing I'll show you is that here are all 5 of the parks that we collected soil from. And you'll see we have, I'll go through the symbols first. You'll see the little houses there. That's the total number of residences that we collected soil from in each residential area. And then the little test tube is the total number of samples for each of those places. And you'll see a little red circle with a yellow X. Those are the places that had the incinerators themselves. So 4 of the 5 parks had the incinerators, while Northgate had not an incinerator, but all 5 parks used the incinerator ash in their structural fill. So Northgate Park is swampy. They filled it out with incinerator ash. And that's why we see contamination in that area. And so all these places were places of concern. If, the residents were saying, like, if there's an issue within the parks, we live all around outside of them, is this issue happening in our residents? So I'm going to show you kind of our results from here. We had a total of 106 residences participate in our project, and then that ended up being 233 total samples. Thanks, Chris. You can advance to the next one. Next slide, please. So I want you to sorry, could you go back one? I'm going to walk you through just how to read our results piece. And so what we see here is this is a range bar. So I'm going to show you the yellow dot is going to show you the lowest bit of contamination that we found in a single soil sample. And that red dot is going to be the highest piece. And you'll see that there's an abbreviation ppm, and that's parts per million. That's just our unit of measurement that's consistent with the Environmental Protection Agency and other things that hits our regulatory standard. And so you'll see our range there. So I'm going to show you, essentially that means that on this graph, you're going to see 2 samples, right? The lowest, the highest. And if you can go to the next slide, those are going to be our edges there. I'll also tell you how many samples were within those ranges of the lowest and the highest. And then give me one more, Chris. And I'll also show you the average for that neighborhood. So each neighborhood will have its average, its lowest and high. So we'll go through all 5 neighborhoods this way. And we'll also go through the 2 metals that we looked at, lead and arsenic. So you're going to see this a lot. All right, so parts per million, low, high, average. We'll also be contextualizing these areas by one, the average number of lead parts per million in urban soils. That's 150 is just that average for what you'd find in urban soils across the country. And then that 200 parts per million, that's our North Carolina safe level. So we'll show you things that go over 200 and under 200. That'll be our where we talk about things. So you can see things are divided into lower risk, they're below that 200, and higher risk are above. Next slide. I'm going to do the same thing for arsenic, but you see that my scale bar is different. So we're looking at just a smaller range of we're looking from like 0 to 40, or just smaller here. You can advance the next one, Chris. So we're still looking at that low, high, average, but our point here is that in our urban soils, our average is from 5 to 7 parts per million, so a lot smaller numbers than what we're looking for lead. And our safe level is 8 parts per million. Okay, so that will contextualize. So here we go. We're going to go through all 5 parks now. Go ahead, Chris. So for Walltown, yes. So our Walltown lead levels, they ranged, our lowest sample was 5.8, and our highest was 2,730 parts per million. And that you can see, of course, that range is much higher than our 200 safe parts per million. But our average overall was 155. So across, I think we had 57 samples total. 47 of them were below that 200. So 47 were in that lower risk category, and 10 were in that high higher risk or above that safe level, one of them being extremely high, right? A whole order of magnitude higher than what our regulatory agencies have considered safe. Next slide, please. For arsenic, we have our 8 here. Our average for Walltown was again above that safe level of 8 parts per million. It was 9.5 for Walltown, and then the highest was 72 parts per million. And so in this case, we had 41 total samples were in the lower risk category, and 16 were in above that 8 parts per million. So 16 of those 57 samples were in the higher risk category. Next. Okay. Shifting over to Lion Park. Here we have our low was 8.4 parts per million for lead, and we went up to 718 parts per million in Lion Park. We had 62 samples that were in the lower risk category and 7 that exceeded that 200 parts per million, with an average of 82.6 parts per million across all those samples. Next. And for arsenic, we have we had an average of 5.3 parts per million, so it was underneath that 8 parts per million safe level. The highest was 26.6, and there were 8 samples that exceeded that 8 parts per million range, and 61 that were in the lower risk category. And next slide, please. Okay, for Northgate Park, we had 39 samples that were underneath that 200 parts per million, with an average of 66.5 parts per million. And our highest sample was 531. There were 4 samples that were above the 200 parts per million safe range, but our overall average was at 66. Okay, Northgate for arsenic. Our range again was 1.4 to 23 parts per million. Our average was 5.4, so that was underneath our 8 parts per million. But our highest range there was that 23, and there were 4 samples that were above that exceedance of 8 parts per million. Next. And for East Durham, we had a range of 10.9 to 842 parts per million. There were 33 samples that were underneath that safe level, and the average was within that as well of 103.7 parts per million. We had 4 samples that exceeded that 200 parts per million, that highest being that 842. For arsenic in East Durham, we had, we had 1.6 parts per million to 28 parts per million. Our average was 5.6, and we had 32 samples that were below that 8 parts per million, and 5 samples that exceeded that safe level, the highest being 28. And we have for East End, our lead ranged from 2 to 311 parts per million. Our average in this case was 82.3. So we had 25 samples that were below that safe level of 200, and 2 samples that were above, the highest being that 311. And for arsenic, our soils range from 1 to 20 parts per million. We had 22 samples that were in the safe range below that 8 parts per million, with an average of 5.2 parts per million. And then our highest sample was 20, and there were 5 samples that exceeded that 8 parts per million. Okay, so that's my going through my park by park. I hope you're able to hold on there. If we look at everything across all the parks, first I'm going to start with just the number of samples that we looked at and how many of them exceeded that safe level. So of our 233 soil samples for lead, 206 were below that safe level and 27 exceeded that threshold overall. So that's what you see in that column on the left. That's all neighborhoods all together. And then you can see the breakdown per neighborhood. So Walltown, there were 10 exceedances for lead, and 47 safe below the threshold, or lower risk, I should say. For Lion Park, there were 7 exceedances with 62 below that threshold. Northgate, there were 4. Um, East Durham, there were 4, and East End had 2 exceedances. Next slide, please. I'm also looking at lead here, and here I'm looking again, I have that all neighborhoods category at the start. And this is the average soil of lead concentrations, average soil lead concentrations. It was 100.8 across all the parks. And then putting them together, those averages, and you've seen these numbers in the slides before, but all together, go ahead and advance that next one, Chris. Uh, the average was below the 200 parts per million of that safe level. Um, Walltown had a little bit of, still did not exceed on average that safe level, but did have the highest amount and also was a little bit above the average lead that we would typically find in urban soils altogether. Now for arsenic, going over the same pieces. So here we're looking at the number of samples overall. And the total number of samples that we had, of our 233, 38 of them exceeded that 8 parts per million, while 195 were below in that lower risk category for all across all of our parks. And you can see that breakdown across for for all of our neighborhoods. Walltown had 16 exceedances, and 41 below that safe lower risk level. Walltown had 8 and 61 below, and 4 for Northgate, 39 below. Okay, perfect. And the last piece here, our average soil arsenic concentrations for across our average across all the neighborhoods was 6.5. Remember, our safe level for arsenic was 8 parts per million. Um, Lion Park, Northgate, East Durham, and East End were below that level, averaging really pretty consistent with that 5 to 7. And actually, this says lead, and it should say arsenic in soils. Um, and then Walltown was just above at that 9.5, above that 8 parts per million. And next, Chris. Okay, so what do these things mean? So as you can see, most of the samples that we got were below the safety threshold values that our state has identified. On average, the residential soils were below those urban averages as well. And we see that 88% of lead samples across all 5 parks were below that 200 parts per million safety threshold. And 84% of the arsenic samples across all 5 parks were below that 8 parts per million safety threshold. So from our initial, this is our first look, but the reason for this study was a concern about is this a widespread issue that are on the parks or across our residential areas? And we really didn't see widespread contamination across residential properties. And so that helps clarify that the contamination that we find in the parks is not widespread across the city. It is centered within the parks themselves. However, we did definitely find exceedances. We definitely found residences that do have to deal with contamination. And so this is consistent with land use patterns historically and currently with incinerators and our industries that are still here operating within Durham. I do want to point out that we had limitations. Our goal of this study was for individuals to understand their own soil samples, and so we we let anybody participated that wanted to within these residential areas. We did not target specific homes and limit our study to specific homes, and also um, because of privacy, we wanted to make sure that people could participate in the study without necessarily having um, revealing their address. So we don't have, and for some of our samples, we only know that they came from a particular neighborhood and don't know their exact address. And so that limits the type of spatial analysis that we could do in some cases. But because our priority was making sure that individuals understood their own results, we made sure to leave that as an option so people could still participate with the lowest risk that they were comfortable with. And we also didn't reach everybody. We did canvass over 600 homes across all 5 neighborhoods, but we had 106 participants. That's not everybody within these neighborhoods. And so uh, there were folks that didn't participate, and we don't know all the patterns of it across all 5 residences. And there also were contaminants that we didn't test. We had 2 metals. We know that the parks also had VOCs, volatile organic compounds, but those were things that we weren't able to look at given our the equipment that we were able to use. So we didn't test everybody and we couldn't look at everything. So this is a snapshot. However, we know more. So even though um, I think this question came from our community engagement and our collective action as an organizing group. And so this can help continue those efforts. We didn't detect widespread residential contamination, but no one should have to live with elevated levels of contaminants inside your home or in your community. And so there are still things that we can do to help keep ourselves safe and our neighbors. Could you wait for that, love? Give me 5 more minutes. I'm really appreciate you want to clean. And my last point is that this is a starting point. We had a lot of questions with any study. We end up having more, and we would love to hear those and keep those coming, but we may not have the answers right now. And so think about this of like, what else do we want to know and what else can we do together? So thank you so much. And next slide, I'll pass it off to our next presenter.
Hey everyone, this is Megan Hughes with the Duke Superfund Research Center. Most of our team lives in Durham, so we work in Durham and we live in Durham, and this issue is really important to us as well. We just want to share some tips about ways to protect yourselves and your families from soil contaminants like lead and arsenic, but also anything else that we come into contact throughout our lives. Really important in terms of lead to wash hands with soap and water, especially important for kids when they're coming in from playing outdoors. Um, Lead needs soap and water and the agitation of scrubbing, and is hand sanitizer is not effective. So you might really want to make sure you're using soap and running water. And then different ways of keeping dust down in your home. Um, Asking folks to take their shoes off at the door, using floor mats, having boot trays or some kind of place where shoes can gather so you can keep those tiny particles at the door and not coming into the home. And then wet dusting, always instead of dry dusting to kind of get those little teeny particles. For folks, parents or grandparents or daycare providers, anyone who is around young children, we say 6 and under, um, make sure they get tested for lead. In North Carolina, that usually happens at age 1 and age 2, but some kids miss those tests. And also, if you are just not sure your child had those tests, or you would like to know right now what their blood lead level might be, there are some resources there with the Durham County Health Department. And next slide, one more. So our team also has lots of fact sheets on soil contamination, healthy garden habits. This fact sheet, if some of you participated in this study, you've probably seen this fact sheet. We have these resources in English and Spanish, and they're available on our website. And if you want to share those with the community, with your neighbors, and you need help getting printed copies, let us know. We can help you with that. But we have lots of resources available, and they're written in a way to be as up to date on all the science that we know about these kinds of pollutants, and also to be accessible to real people. I also just want to note we're seeing your questions come through the chat. We're going to roll back to those at the end, so just hang on and we'll get to those. And I'm passing it on to, I think, Mary.
Good evening, everybody. My name is Mary Unterreiner. I work for Durham Parks and Recreation. I manage our communications outreach and engagement for the department, and I'm just here to talk through next steps as it pertains to the parks impacted by this. And so we were involved in the soil shops, just providing this information and the future of the parks. Right now, we are expecting to receive summary reports from North Carolina Department of Environmental Quality for all 5 parks this month. We're expecting that those summary reports are going to cover where contamination exists, what kind of contamination is present, the amount, and how it may be moving through the environment. They've analyzed soil, groundwater, surface water, sediment, and gas. And then we're also expecting to hear more about the associated potential risks. These reports are going to be different from the remedial action plans, which are the highly technical, comprehensive reports that are supposed to come out of this process. However, these summary reports are going to provide us enough information to hopefully begin working with the community and working with DEQ and city leaders to understand what steps we can take in the shorter term to address concerns in the parks based on the data, as well as any short-term solutions that might allow the parks to be safe and functional again. So we'll explore all of those approaches as well as associated costs to address those concerns. We'll continue to seek community engagement and feedback. As far as funding goes, we currently have $12 million in capital improvement program funding. It's available for these sites. We're also prepared to explore all funding options when we understand what additional funding is needed. We will also be scheduling open houses for the community to review the reports once we have them available. You'll be able to come talk to us about them, learn more about them, ask questions, and provide us feedback. The image on the right of the screen is just kind of our thought process as we're working through this and trying to figure out what the future of the parks are without really knowing what this future date is, where all, our ultimate goal will be achievable of safely reopening all 5 parks. So this is a little outdated. I apologize. We're past fall winter of 25, but we're in the spring of 26. As you know, we're still kind of in that same spot. We're looking for some alternative solutions, again, that could make the parks accessible and functional again. We might be able to reopen some areas where it's found safer than maybe we initially thought. We might be able to rebuild some playgrounds in different areas, maybe relocating park features outside of existing waste boundaries, and invest in improvements in nearby parks, as well as continuing to plan for the parks with the community. And our goal really is to not only reopen these parks, but to make them, take it as an opportunity to make them better than they were before. All of the information about this process is posted on dprplaymore.org/516. You'll see every update we've given the community posted in different, timelines, as well as, current updates. Same with every report that's been published on this process and plain language summaries. If you have any questions, want more information, want to talk to me or somebody else further about what we're doing, you can also email dprengage@durhamnc.gov, and we're happy to answer any questions you might have or talk through this topic more. And that is it for me. I'm not sure who's up next. Thank you.
Hey there, I'm Katie. I'm part of the NC State group that's been helping with this. I'm going to put a link in the chat. We have a short survey that we'd love for you all and everybody else who's participated in the soil testing to fill out, because we really want to try and make sure we can capture all of the remaining concerns and questions you still might have about your soil testing, next steps, things you can do to protect your and your family's health. To think about interventions we might be able to support you all taking individually or collectively. And by collecting this data in a survey, we have really important information that we can show to funders about why projects like this are important and why we need continued support to do them. So I'm going to put this link in the chat. Don't feel like you have to fill it out right now. We'll also send a follow-up email. And then we're going to get into the question and answer for about 15 minutes. We see them in the chat. So I think we'll probably need to start with Danny and Chris. So one of the things that came up throughout the chat is this idea of like, how do the levels we're seeing in people's individual XRF measurements compared to the levels we saw in the parks? Did we see spatial patterns or anything like that? And I think you all speaking to kind of like the intention of how we did sampling and privacy management and what we can and can't say would be really helpful.
Yeah, I can start that off. And first, since we didn't have a ton of time, I put into the chat just now, like, we didn't come up with the term soil shop. This is a process that is encouraged by the federal government, because these are problems of soil contamination in urban areas and across the country. And so hosting soil shops is a way for people to get some of that information. And one of the things that is like central to soil shops, because there are potential legal ramifications or reporting requirements for finding lead or other contaminants within one's soil. For participating in a research study, usually we don't want to do harm to people participating, and so largely soil shops have anonymity baked into them, or at least like their physical locations are anonymous. And so, we bake that also into our approach to try to protect folks as much as possible. And so for that question of, can we do some larger scale spatial analysis? I think there's reasons for that, but that also introduces potential harm for people that participate, and not only for the people that participate and consent to that, but also their neighbors that may not have consented to that. And so that's why we try to keep that information private. And so while I think it's an important question, it's one that we can't quite address in this way without potentially causing harm for people that don't consent to that process. So um, there's a couple of pieces on that of how we try to get around that, like not around that. Consent is important across anything. But um, we try to make this information useful for overall organizing. And so individuals can continue to share their own results with their neighbors, right? So in terms of like what's going on with different locations, that is something that neighbors can talk to each other about. So once folks know more about their own residences, they can share that information. And it's just not something that we can share as people that took these results. And so there's that piece of like we still want to encourage and support folks on collective organizing and advocacy. So that's something that individuals can absolutely do. Um, and one other piece on a question was trying to contextualize what's happening, the levels and averages that we found in residences and also within the parks. And DEQ has taken a lot of samples. We have some of the results that we have are, as Mary said, we're waiting on DEQ's most recent report, but we have data from 2024 when they sampled all 5 neighborhood parks. And for Walltown, the maximum that they had was 1,290. East End, oops, okay. Uh, East End, the max was 261. East Durham was 3,150. And Northgate was that max was 3,480. The averages, oh, and I'm sorry, in Lion Park, the max was 626. Um, the averages all were below 200, except for East Durham, which was the average was 485. And so I know that was a quick and very dirty like overview of what the contamination pieces looked like. Um, but I know that we'll get more information from DEQ upcoming and likely this month on what that scope is. And part of what our role has been as well has been to try to take that information from reports and make them more accessible. And so we'll continue to do that work as well. So I'll pause here for other questions and points.
So there's a couple of questions in here about further testing, either people who got their soils tested through this project and their levels were high, so they want more testing, or people who know neighbors and friends who were not able to get it tested through this. So I know in our fact sheet from the Duke folks, we have some resources. Maybe we could put the links to those in the chat right now. And then also, oh, and I don't know if you're able to speak to, but like one person had a specific question about, do they need to ask for a certain number of samples, or do they need to tell anything specifically to these companies to ensure that they get the most bang for their buck in paying for soil testing?
So if you're sampling yourself, I believe there are guidelines that we distributed earlier on, and we can probably redistribute again on how to take a representative sample. So if you're, but basically sampling more than one spot. And if you're sampling a garden, sampling sort of the rooting zone. And if you're sampling areas where you think there might be exposure to surface soils, sampling more shallowly. Um, but a lot of times those companies, if you actually have somebody come out and do it, they'll give you your own guidelines and they'll give you specific guidelines that can help as well, or provide some guidelines when you contact them about submitting samples. But I think we have some resources too that we can share on that as well that we use during canvassing.
And for the question of like, is it still possible to submit to a local soil shop? That that's a great question. We did find that when people know more about results, they wanted to get more testing done, and so we saw that we try to open it up so that everyone from all 5 neighborhoods could go to any of the soil shops. Um, I will maybe point you back to that survey because we are at that is one of our questions. We of like what people would like more information on. Would they like more soil samples? Would they like help with interventions like raised beds or other things like that? As Alexis mentioned, we were able to do this study because of some support from the Robert Wood Johnson Foundation, and we have a limited amount of time and resources to continue this. And so your feedback on what would be most relevant and important for you can help us make decisions on how we can support folks with this certain amount of funds that we have and time that we have, and also how to build for more things in the future. So I think anything is possible. We have to figure out what's a priority for our community. So please let us know what you think there, and that can help shape our future directions collectively. And if we have a couple of minutes, we've been alluding to the legal ramifications, potentially of soil contamination and what that means for homeowners and things like that. And it's tricky. And so we have asked for help on that, and happy to have on the call a lead lead attorney, lead counsel for um, uh, Southern Coalition for Social Justice on the environmental justice lead. That's Ann Harvey David, who's been working on this issue to try to figure out, essentially make a fact sheet for people to be able to make their own decisions and understand more about the legal contexts for soil contamination. Anne, can I hand it over to you for a couple minutes to talk about that?
Sure. And at this stage, what I'm really looking for is what people's primary concerns are to inform this um, educational resource that we're creating. Just, as the lawyer, got to make the disclosure that this is an educational resource only. Obviously, for everyone's specific situation, you'll want to consult an attorney who can give you advice on your individual circumstances. But we are creating these fact sheets that just outline, what the general obligations would be for people who learn that their soil is contaminated. And so, I've got the chat open here, and if people have specific questions of the type that they'd like to have answered in those fact sheets and want to pop them in there, that would be helpful. You can also probably email Chris or me. My email is pretty easy. It's just Ann with an E at scsj.org. If you have those questions, and don't be surprised if I don't respond to you directly, other than to say thank you for your input. We'll use this to factor into the fact sheets that we're creating, because we do represent some folks in this already, and need to be cautious with how we handle that. But if if folks have questions and want to share them in the chat or share them later, then we can hopefully have those available in a week or two to share broadly with the group, just so folks are aware of what their general obligations may be.
Wonderful.
Thanks,
Thank you
Chris.
so much. Yeah, thank you, Anne. And I think that actually that is just a really great point in general of what we have in terms of at our advantage in terms of our community. Most of us here on this call are Durham residents. A lot of us live near the parks ourselves. We have seen this issue in Greensboro, in Raleigh, and other places, and we have a lot of collective experience on trying to be able to advocate for our own individual health and navigate that for ourselves and our families, and also our neighbors and collectively. And so we have an incredible amount of power to, I think, to be able to have success in this. And the success, I think, looks like really reducing our health impacts from a really common, unfortunate exposure, being able to have parks and spaces that we can continue to enjoy without harm. And I think we really look forward to continuing that work with you all. And I want to thank Alexis and Toxic Free and C. I want to thank, Duke Superfund Research Center, the Center for Human Health and the Environment, um, Conservation, the North Carolina Conservation Network, and also the City of Durham and Parks and Rec. All of us had to really put our heads together to figure this stuff out. We do have a lot of collective expertise, but not all on all the same things. So we really had to pull things together to be able to work through this and many other challenges that we'll continue to work together on for advocating for our parks and residences. So I'll hand it over to Alexis, but thank you so much for everyone's support here.
Great. Thank you so much, Chris. Thank you, everyone, for being here tonight on a Monday night. We appreciate your time. Encourage you, we'll send a follow-up email with everything we've talked about tonight, including the survey link. If you're not already on the Durham Contaminated Parks listserv, we encourage you to join that listserv. We'll include information in the follow-up email about that as well. But thanks for coming out tonight. Thank you all. It's been a pleasure to be a part of this project, and we look forward to being in touch. Take care.
Thank you.
Thanks.
Cool. Yeah, thanks.